Okay, let's be honest. Have you ever been hit with a massive cake craving, zapped a mug cake in the microwave, and then pulled out something, well, something tough and rubbery? You are definitely not alone. Today, we're going to dive into the actual science of why this happens and how a little bit of chemistry can take your microwave cakes from genuinely awful to truly remarkable. I mean, this just says it all, right? This is a cry for help from a Reddit user that I think we can all feel in our souls. It's that moment of pure baking betrayal. You did everything that 30-second video told you to do, you were promised a quick, gooey treat, and instead, you got a science experiment gone horribly wrong. Yeah. It's that sinking feeling, isn't it? The promise of a dessert in minutes turning into this dense, chewy hockey puck. It's a surprisingly common experience, but it really makes you wonder why. Why does it go so wrong so often? So let's just call this what it is, the mug cake catastrophe. It's that huge, disappointing gap between the delicious cake we picture in our minds and the sad reality we pull out of the microwave. And here's where it gets really interesting. This same user who said their cake looked like a gore video, which is just amazing, also said the flavor was actually pretty good. And that gets right to the heart of the issue here. This isn't a problem of taste. The sweetness, the chocolate, that's all there. This is a problem of structure. To figure out why that structure completely falls apart, we've got to look at the huge difference between how an oven and a microwave actually heat your food. It really all comes down to the science of how heat gets transferred. Think about it. A regular oven works from the outside in. It uses conduction, heat from the hot pan, and convection, which is just hot air swirling around. It's a slow, gentle process. A microwave completely flips the script. It uses radiation to cook from the inside. Now, that word radiation can sound a little scary, but in your kitchen, it just means that energy waves are shooting right into your food. These waves make the water molecules inside the batter vibrate like crazy, and that friction generates a ton of heat, super fast. There's no slow bake here. It's an intense, high-energy party at the molecular level. And that speed, well, it's both the microwave's greatest superpower and, for a delicate cake, its biggest flaw. So, before we get to how the microwave completely wrecks everything, let's do a quick recap of what's supposed to happen when you bake a perfect cake. What are the essential building blocks? It all boils down to two key things, structure and lift. So that structure, that comes from flour, and this is important, not all flours are the same. It's all about the protein content. So bread flour, for example, is really high in protein. We're talking 12 to 15%. That creates a lot of gluten, which is perfect if you want chewy bread. But for a soft, tender cake, you want the exact opposite. You want a low-protein flour like cake flour for a much more delicate crumb. You can think of gluten as this kind of network, like a molecular scaffold that holds the entire cake together. The amount of protein in your flour decides how strong that scaffold is. For an amazing cake, you want that scaffold to be delicate and light, not tough like a brick wall. And then you have lift. This is just basic chemistry, that classic acid-base reaction. You take baking soda, which is a base, and you add it to a batter that has an acid in it, like yogurt or buttermilk. Once you add heat, they react and release carbon dioxide gas. It's those little gas bubbles that get trapped in that gluten scaffold we just talked about, forcing the cake to rise up and get all light and airy. Okay, so we've got our delicate gluten scaffold, we've got our rising CO2 bubbles. Everything is working together beautifully. Now let's bring back the microwave and see exactly how its super fast cooking method just blows this whole delicate system to bits. Right, remember, this is not a gentle, slow bake. The microwave radiation is so intense that it makes the protein set and the water evaporate at a ridiculous speed. The entire process of building the cake structure, which should take like 20 or 30 minutes in an oven, is just violently crammed into maybe 90 seconds. And that molecular chaos is exactly where things get rubbery. And here is the real science behind that rubbery texture.
Research shows that microwaving literally changes the shape of the proteins. See, in a normal oven, proteins form these nice, stable, orderly, spring-like things called alpha helices. But look at this data. The intense energy from the microwave makes those orderly structures decrease, and instead they form these tangled, messy clumps called beta sheets. It's like taking a neat ball of yarn, and in 1 second, it's just a hopelessly tangled knot.
And that is the secret. That's why it's rubbery. Instead of a delicate, flexible scaffold, those gluten proteins unfold way too fast and get tangled up into this dense, chewy mess. So it's not you, it's not your fault. It's just science. It's a totally predictable result of throwing that much energy at these poor molecules so quickly.
Okay, so now that we're armed with the science behind the catastrophe, how do we actually fix it? We can totally use this knowledge to outsmart the microwave and bake something that's genuinely remarkable.
It really comes down to a few simple fixes based on everything we just learned. First, to fight those protein tangles, use a lower protein flour, like kick flour or even all-purpose. Less protein means less gluten to get all tangled up. Second, make sure your cake has a fighting chance to rise by having an acid in there for the baking soda. Third, fight that rapid water loss by making sure there's enough moisture. Maybe add an extra splash of milk. And finally, maybe the most important rule of all, do not overcook it. Start with 1 minute. You can always add 10 more seconds.
And when you get it right, the results can be pretty fantastic. When you actually apply these ideas, you're working with your microwave instead of against it. And the goal is this: a cake that is truly light, tender, and delicious, with absolutely no rubber in sight.
Ultimately, your kitchen is just a small lab. That mug cake that went wrong, that wasn't a failure. It was data. By understanding the why behind it, you've just turned a baking disaster into a cool lesson in food science. So the only real question left is, what are you going to experiment with next? Thanks for joining us on The Explainer.